So basically, the whole idea of the ICGEB started long ago, more than 30 years ago. So even before the course of this course, that this is one of the landmark papers. I'm showing this for the young people because I think this is good to see history, how it goes back. It's a paper of Stanley Cohen, Robert Boyer, and other in Stanford, and it is the first demonstration of cloning, basically, of transferring a piece of a gene from one organism, in this case SV40, to another organism, in this case a plasmid. And that was the basis upon which in the early 80s the Lilly company in Canada produced insulin. 1982 is the first biotechnology produced recombinant protein, in this case, reaching the market. Now you know that there are more than 300 different products obtained through these technologies. Again, we go even more back to the beginning of the last century. And this person is Irving Smith. He was an employee of the U.S. the U.S. Department of Agriculture. And then he was interested in tumor of plants, sort of plant cell proliferation, so that he thought they were resembling human tumors. Actually, he was also the president of the American Society for Cancer for several years. And instead, what he had discovered was a bacterium that was infecting plant cells and transferring genes into plant cells. And then, again, in the 80s, different laboratories, including one in Belgium, discovered a way of taking advantage of this to do gene transferring to plants, and that was the birth of plant genetic engineering. And the third part of the story dates back again to the same years, 1975. This is the first paper by an Argentinian PI, Cesar Milstein, with a German postdoc, Köhler, and they described a way of obtaining immortalized cell line producing only one antibody with a defined specificity. And that was the birth of genetic engineering. And so if you look at now what has been the impact of these technologies into economy, for example, you can have a look at this table, which is produced by this Vantage EP, which is a survey company for the pharmaceutical industries. And this is the list of the 10 most profitable drugs in the market. The first one is a monoclonal antibody, it's Humira. It's a monoclonal antibody against TNF-alpha. It's used for several osteoarticular disorders, mostly. It sells alone more than $10 billion per year. The 10th one sells $5.5 billion per year. Well, in the first 10, there are only 3 small molecules, and all the other 7 are products obtained through genetic engineering or monoclonal antibody production, so through biotechnology. So there are 5 monoclonal antibodies and 3 recombinant proteins. So it was more or less in this kind of scenario that in the late 70s and in the early 80s, people at the United Nations, the Industrial Development Organization, the UNIDO, start to pose themselves a very simple question. If this is the development of technology that will be going to boom and to take over the pharmaceutical industry, a large part of the most profitable pharmaceutical industry in the next 20, 30 years, who will think at developing countries for? That was the time also when the most successful companies in US were founded. So Genentech, 1976, Biogen, Amgen, Immunex, you read the years here. So who will provide this technology for developing countries? And this is the reason why these functionaries started thinking of setting up a center who had to be at the benefit of the developing countries. And in 1982, there was a first meeting. This is a picture taken from that meeting. This is the delegation from Yugoslavia. This meeting was organized by UNIDO in Belgrade, and there was a discussion where the center had to be. A foundation meeting was held in Madrid, Spain, and in this meeting, Italy puts forward its candidature to host the center, but that was not enough because there were other countries wanting to have it. Cuba was one of these, Spain itself, Yugoslavia, the Netherlands, and then also India. Indira Gandhi at that time had a strong interest, and then things went forward until 1987 for additional 3 years, until it was decided to have a center with one seat in Trieste and another seat in Delhi and in India, and the headquarters here in Trieste. The center continued to work as a special project of UNIDO until 1995. In 1995, it had a sufficient number of signatory countries to become an independent operation. So now the ICGEB is an independent international organization in the United Nations system. The reason why it was decided to have it in Trieste is twofold. First, in Italy, because there is a strong support by the Italian Ministry of Foreign Affairs within the framework of the Italian cooperation. Second, Trieste, because it's very central in Europe. And third, because you know that Trieste has had a very troubled history. So it was has been for 800 years an Italian city, but under the Austrian Empire. So this was the main harbor of the big empire, Austro-Hungarian Empire, the main harbor on the Mediterranean Sea. So it grew much larger and richer at that time, and that lasted until the First World War. At the end of the First World War, Italy went back. Trieste went back to Italy. It was still at the center of a big region, which was Italian, that includes all the coast that's now Slovenia and Croatia. But at the end of the Second World War, all this territory was lost to Yugoslavia. Trieste itself was uncertain to go back to Italy for additional 8 years after the end of the war. And only in 1953 it went back to Italy. But at that point it had lost all the territory around. The border to Slovenia is less than 2 kilometers from here. You can see it from the windows here. And so as a sort of political recompensation for the lost territories, the Italian government in the 70s and 80s decided to transform this city into a city of science. So now we have a regular university plus a university for PhD studies, the International School for Advanced Studies. We have 3 centers of the United Nations. The first one dates back 50 years, the International Center for Theoretical Physics. There is the Third World Academy of Science. There is this very science park, which is one of the largest in Europe. It's called Area Science Park. There is a synchrotron close by for acceleration of electrons, and so on and so forth. There is a statistics that says that the average people working out of science is 8 out of 1,000 in the United States, 6 out of 1,000 in Europe, 5 out of 1,000 in Italy, and 36 out of 1,000 here in the Trieste region. The ICGEB works under the support of 64 countries. These include basically all countries in South America and Central America, those that are in green or yellow in this map, 2/3 of Africa, the vast majority of countries in Asia, and all the countries in Eastern Europe. These countries were belonging to the category of developing countries if we date back this definition 30 years ago. Now, I mean, we can debate which is developing, which is developed. These countries include Brazil, South Africa, Russia, China, India themselves. And the center has 3 main laboratories. One is here in Trieste, the place where we are now. A second one, which was born basically almost simultaneously, is in New Delhi. At the periphery of Delhi, there is a big campus that hosts several buildings for the ICGEBs, 2.5, 3 times bigger than this here in Trieste. And in 2007, there's been an additional setup in Cape Town, in South Africa, with the idea that the center in South Africa should act as a sort of hub for training and education and research for the rest of the African countries. And we work in close collaboration with more than 40 affiliated centers that are national laboratories in our supporting countries. The list of supporting countries has grown steadily over the years. As I just mentioned before, there are now 64 of them that are supporting the ICGEB. And basically, we do 5 kind of activities at the ICGEB. The first is to run research at our own laboratory. So we want to be a research institution, and we want to be a research institution that performs in a, let me pass the name, the competitive manner with the best places all over the world. So we use the same parameters that are used to judge science everywhere. So number of publication, quality of publications, impact factors, H-index, and so on, as so forth. The spirit of ICGEB is somehow summarized in this publication that is from last year. This is a publication from my group in which I share the last co-authorship with a junior scientist, junior PI from Belgrade, so from what is now Serbia. The first author is a PhD student from Italy. The second author is a PhD student from Hungary. This is a postdoc from India. This is again from Serbia. This is from Poland. This is from Hungary. And all the work has been conducted here in Trieste. So I think that this gives you the spirit of what we mean for cutting-edge research. Then we provide fellowships to scientists from our 64 member states to join the laboratories in Trieste, Delhi, and Cape Town. These fellowships are really given with an international attempt to be as spread as possible. Here in Trieste, there are people from more than 25 nationalities now working currently here. This is the spread of nationalities that have been awarded our fellowships. There is a transparent manner for selection and awarding, so we have international calls for PhD fellowships and for postdoctoral fellowships, and these also include, both of these categories include also short-term visit, support for short-term visit to the laboratories in our 3 components. Also in terms of education, we run a large series of meeting, courses, seminars, workshops, both in the 3 laboratories of the ICGEB and worldwide. This is one of these meetings. There are more than 20 of these events organized every year. Also in this case, we have we try very hard to have a broad geographical distribution of participants. The spirit of this meeting, and you will see also during this course, is to invite top speakers in a given specific field, so they are the best in the world, but at the same time to provide fellowships to scientists from our member states, to give them the possibility first to hear lessons so be exposed to advanced teaching, but also to have the possibility of having a physical and personal contact with the speakers, and so giving a unique opportunity to provide a forum for interaction. As I told you, these courses are international. This is a list of courses that we are organizing in 2016. You see, these are the courses in Italy, but you can see very easily that they are spread all around the world. And also, we have a call for application for the organization of these courses, so we receive every year by the end of February proposals to host these courses, and proposal for the ICGEB to support economically these courses, and then a committee decides which one to award every year. A fourth activity is to directly finance research projects in our member states. And every year we give approximately 20 of these grants. These grants are also geographically very spread. These are the active grants in Latin America, Africa, Asia, and Europe at this moment. These are very, very competitive. Basically, the success rate is less than 20%. And there are some categories that might be of interest also to some of you. For example, there is one category of these grants in which we finance early career return grants. So if there is a very successful PhD from one of our nation states who have performed extremely well in Europe, UK, in the US, and wants to go back home and establish his own or her own research activity, well, we provide him or her with seed money to start this kind of research for 2 or 3 years. And the fifth line of activities we conduct is to work in close relationship with industry. This is even one of the points that are statutory in the foundation of the ICGEB. The name of the center is the word biotechnology, which implies not only advanced research but also application of this research. So we try to patent our science. And then we have 2 special activities, one here in Trieste and another one in Delhi, for technology transfer. As I started this presentation recalling the production of recombinant proteins in the early 80s. Well, most of these proteins, all of these early proteins are off patent now, so everybody can produce and sell erythropoietin, insulin, GM-CSF, the interferons, and several monoclonal antibodies. But obviously, you need the technology to do that, and the technology to produce a biotechnology product is by far more complicated and has to be more personalized than the technologies to produce small molecules. And so basically here in Trieste we have a facility for the production and the setup of these methodologies to produce a few products, so GCSF, interferon, EPO, insulin. Now we're starting with monoclonal antibodies, and we've signed more than 70 technology transfer agreements with companies in our member states, which the states are those that are depicted here, to which we transfer these technologies. In Delhi, instead, we have 2 big programs, one on malaria vaccine and one on dengue vaccine, which are proceeding toward clinical experimentation, and we have a record or more than 20 different diagnostic kits, which are sold in 40 countries almost in Asia for the diagnosis of infectious disorders. So we have produced in close contact with Indian companies kits for the diagnosis of HIV, dengue, different hepatitis viruses, and chikungunya. The governance is composed by a board of a representative of the 64 member states. They meet every year to decide what will be the shape of the activities for the subsequent year. The meeting will be in May this year, 2016, in Cape Town in South Africa. And the scientific activities are supervised by a scientific council, which is composed by 15 eminent scientists. There are 2 Nobel laureates currently serving in the board, so Rich Roberts and Harald Zurhausen. Rich Roberts got the Nobel Prize for medicine and physiology for the discovery of splicing. Zurhausen is the first person who discovered HPV as the cause of cervical cancer. I'm going to the end of this very brief overview, just to say that what we do here in Trieste, most of the activity here has a biomedical flavor, so we are interested in different fields of biomedicine. The activity is very spread because obviously we have a focus on education, training, and so we try to keep several areas covered. We run projects in basic molecular biology, more applied projects especially in cardiovascular disorder and neurodegenerative disorders. Within these projects, we use currently the most advanced techniques in gene therapy, in stem cell therapy, now in the CRISPR-Cas9 editing, and so we try to keep really research at the frontier of technology too. In India, there are 2 big departments. One is dealing again with biomedical application, mostly on infectious diseases, so malaria, dengue, hepatitis. And then the other department instead is focused on plant biotechnology. So there are several groups working on the possibility of engineering plants for food production and for the production of energy, so of bioenergy. And instead, the capital component has been kept at a no growth rate since 2007. There are only 5 groups who are interested in parasitology and infectious diseases that afflict the African continents and also cancer. We are now just in the final phase of negotiating with the South African government an agreement that will allow this component also to grow at least as big as the components here in Trieste and in Delhi. That was my last slide. You will hear me again speaking tomorrow about my own work on the work of my laboratory, I should say, on the microRNAs and their application in cardiovascular disorder. But this is all what I wanted to show you. And so have a good few days here in Trieste. Enjoy the science, enjoy the place. I'm sure the course will be outstanding as it has been in all the previous years, and I'm very happy to take questions if you have any now. Thank you very much.